Joining me now, Auckland University nanotech scientist Michelle Dickinson, to talk about what, on the face of it, Michelle, good morning.
Good morning.
On the face of it, does sound a little vampire-esque, the idea that you essentially sap blood from young people, put it into old people, and the old people live longer.
Yeah, it does, doesn't it? I mean, there's no sucking of blood happening here, so it's not quite like that. And
They donate it willingly.
Well, it's not whole blood either, so it's blood plasma. So
Right.
you spin the blood, you take the platelets out, and then... So blood is really interesting because it
So you
carries...
can't just hook, you couldn't just sort of go out onto the streets and get a young, I don't know, you've got to be careful how you say these things on air, but get a young person and lie them down. You'd have to comatose them. I don't know how you'd do that because you wouldn't want to harm them. Well, not permanently. Keep them under coma, and you'd put them on a gurney, and you'd lie on a gurney and just plug yourself into them. You can't do that.
You can't do that, no,
okay,
and
good.
I wouldn't suggest that anybody should do that.
So how is this done?
But the experiments initially were horrifically like that. So they tested on mice first, and what they did was take two mice, literally open them up, transfer their circulatory system, so they were like Siamese twins.
So one young mouse, one old mouse.
Right. And when they didn't genetically match them and age match them and character match them, one of them would eat the head off the other one. That's how traumatic it was. Luckily, we have things called ethics now. So now they match the mice together and they make friends for a while before they connect them, and they seem
So
to
they
do
put them in
this.
the same container just so that they
just to hang
can
out.
muck around.
Right, and they
then
actually connect their circulatory system. So the blood from the young goes into the blood of the old mouse. And what
It's still quite horrific, the things you
it's less
scientists do,
horrific.
Michelle.
I've been reading some research papers over the weekend, and it's much less horrific. It's still not an experiment I would want to do. But you've got to get the blood in on a long-term basis. So, I mean, what did happen is the old mice seemed younger. They had better memories. They could run for longer on treadmills. Obviously, they've got their little buddy still on the side of them. And the young mice who were getting the old blood in were getting older, so having, less memory and stuff. So the theory from those...
So it's like a double check, really, so you know that it's working.
So the theory from those older experiments, which have got much more ethics in now, were maybe there's something in the blood, because the blood has nutrients, blood has messengers, hormones, and proteins. Now scientists are trying to figure out which proteins are important for this factor, as opposed to just transferring the whole blood. Because ideally, you could take that factor, they're looking at something called GDP, growth differentiation factor number 11, which seems to be one of these factors and proteins. Oxytocin, the love hormone, seems to be something that we know are declining.
Okay, so which part of this is
right?
the
There are
vital thing?
hundreds of proteins and messages, right? So we're trying to do that, and then hopefully synthetically create it so that rather than you having to transfer.
But
the
even
blood.
if you had to, because they're now doing tests in humans, or they're about to start
They've
tests in humans.
started doing it in patients with Alzheimer's, and so they're taking young people's blood plasma, but actually they're classifying young as under 30, and so the mouse studies have shown that you actually need the blood to be much younger. But it's the first initial human trial. Results should be out in December to see whether these patients with Alzheimer's, and it's mild to moderate Alzheimer's who are age 16 plus, are
They improve.
Right, because there's anecdotal evidence. So there was a patient in Hong Kong who had blood plasma for another reason, and he had Alzheimer's, and actually his recollection of his memory was better.
And it seems to make sense to a because I didn't finish medical school.
Did you start it?
Not exactly.
You just Googled
No,
it,
I didn't
right?
completely start it, which is to be hand in glove. That's why I didn't finish. But it seems logical that if you refresh someone's blood, given that the blood is the food of the body, that you would improve. And so the upside of this is, even if they can't create it synthetically, if it works, you could essentially farm it, which is what they do now in blood banks.
You could. And so what you don't want to do, though, is just put a whole bunch of stuff into your bloodstream. And so it's how do you identify these proteins? And there's so many of them that actually people are just concentrating on one. But there's been great research over the past 2 years from 3 very separate universities doing this sort of thing, showing positive results from these hormones and these plasmas.
So as you look at all of the results from the surveys linked with this, do you say, yes, they're definitely onto something? So
sadly, in Nature, a couple of months ago, the opposite was found. So the thing with any study is you do a set of studies, and so GDP 11 was initially found to be better for the brain. Now it's supposed to not work, and so you need actually more results. So we're still in this limbo, but now we're trying it on humans. December we'll find out.
We'll have some idea.
But if it works, Michelle, you can be the live forever guy.
Thank you very much. And I think it's a good idea. It seems I'm not quite sure what the end game is. I suppose because living forever creates all kinds of other problems. But anyway, Michelle, thank you very much for joining us, nanoscientist Michelle Dickinson.